What is gamut? Put simply, gamut means range. A color gamut is the full range of colors that a device like your monitor, your printer, or even your eyes can reproduce or perceive. Different devices have different gamuts, some larger, some smaller. Your iPhone screen, very large gamut. Your standard desktop printer, much smaller. And your DTF printer, that actually depends. It depends on the ink set, the RIP software, and the substrate being used. Before we go deeper, if you watched our last video on color spaces, you already know how RGB and CMYK define color using numbers and why that matters. This video goes one step deeper into color gamut. What's actually possible to reproduce and what isn't. But here's something important before we continue. You don't need to memorize all of this, just absorb it. Let it start to click. Use this video as a reference, something to come back to as you gain experience. First of all, why should you care about gamut in DTF printing? I want to spend a minute on the why because I really do think understanding this is important. It's foundational knowledge that brings a lot of other topics into focus. Can you get away without understanding color gamut? Yes, but if you're serious about integrating DTF prints into your product offering or production workflow, not understanding gamut will be a handicap. Let me give you a few examples of where this knowledge pays off. Choosing the right design tools. Illustrator and Corel give you far more control over color spaces than web-based tools like Canva, Kittl, or even ChatGPT's image tools. Avoiding screen-to-print surprises, because what looks great in RGB on your screen may fall flat when it's converted to CMYK and sent to print. Communicating clearly with your clients, designers, or your print provider, especially when the job involves brand-critical colors. Troubleshooting. When colors shift or things don't match, understanding gamut helps you know what's going on and what to fix. Delivering for demanding clients. Sometimes a quick file export won't cut it. You might need to do test prints or controlled variations to lock in the right color. And here's something else that I personally think is really important. The more you understand color spaces, and color gamut, and how they relate to DTF, the easier it is to see through the marketing spin. If you spend any time in DTF Facebook groups, and to be clear, there are some really great communities out there, but you've probably seen other stuff like this. Unmatched vibrancy, color charts that solve all of your color match problems forever, or use this magic RGB ink set for the most accurate, vibrant colors. Some of this is just straight up bad advice. And if you fall for it, it costs you time, it costs you materials, it costs you money, and worst, it can cost you client trust. Let's get back to gamut. Gamut is a range of colors you can reproduce. In DTF printing, you're working between two key color spaces with two different gamuts, and those spaces are RGB, which is typically used for screens and digital design, and CMYK, used for printers and ink. Now let's talk about RGB versus the CMYK gamut. Here's the basic comparison. RGB has a very wide gamut. CMYK has a much narrower gamut. In plain English, RGB has a lot of crayons in the box. CMYK, just a few. That's why electric blues, bright oranges, and vibrant greens often look great on a screen, but may appear dull or shifted in print. So how many colors are we talking about? Let's look at the numbers. RGB can define up to 16.7 million colors, but under ideal conditions, the human eye can only distinguish maybe 1 to 5 million of those colors. Before we continue, let's unpack that extremely important concept of distinguishable colors using a very oversimplified but accurate example. RGB can create 16.7 million colors. You can only detect, say, 1 to 5 million of those colors. Now let's use an example to bring that into focus. Pure red, by the numbers, in the RGB color space is defined as 25500. That's 255 for red, 0 for green, and 0 for blue. Now let's focus even further on just the red value. How far can we move that red value before an average person will be able to detect that one red is different from another red? The answer is that you can start to see the difference when you get to a red value of about 245. So while 25500 is technically a different red than 25200, your eye can't tell the difference. Now, once you get to 24500, then most people can start to tell the difference. So in summary, RGB has 16.7 million color possibilities, but you can only detect, discern, or distinguish between 1 and 5 million of those. CMYK can define around 1 million colors on paper. However, on DTF film or fabric, due to ink limits and substrate texture, that number drops to around 20,000 to 50,000 visibly distinct colors. That's a useful number to understand, but it's not the whole story with DTF. Modern commercial DTF printers, like the ones we use at Demand Prints, have an expanded gamut because the ink systems include color expanders and neons. These systems can produce well over 100,000 distinguishable colors. So to recap this, the distinguishable RGB gamut, 1 to 5 million colors. The distinguishable CMYK gamut with DTF printers that have expanders and neons, well over 100,000 colors. To help this make even more sense, let's do a demo. Let's think about what these different gamuts mean for DTF printing when you go from a digital design on a screen to a physical print on fabric using a practical example. Imagine you're creating a design in Kittle or Photoshop and you're designing using the RGB color space that has a wide or large gamut with millions of colors. Here's some artwork we use a lot for examples called Monster. It's very colorful. It's designed in the RGB color space. For this design, I have access to, let's say, 1 million colors for easy math. I know it's 1 to 5 million, but let's just pick a simple number. When I print it, the gamut or range of colors drops to, let's say, 100,000 colors. So when I print that, 1 in 10 colors could be an absolute perfect match by the numbers. 90% will have some variation based purely on the numbers. And the reason, the RGB gamut is much wider than the CMYK gamut, even with expanders. At this point, you might be thinking, wait a minute, when I'm using DTF, are my prints gonna look terrible and have all the wrong colors? Don't panic, not at all. This is where we need to step back for a minute and separate the science of color, the numbers used to represent color, from the experience of color, which is what your very human, very squishy eyeballs actually see. Your eye, and more importantly, your customer's eye, doesn't see math. It sees color. It sees the full picture. And the truth is, the eye is incredibly forgiving. What do we mean by forgiving? When we say the eye is forgiving, we don't mean it's lazy, we mean it's smart. It adapts to lighting, it fills in gaps, it rounds off the edges. It makes color feel right, even if it's not mathematically perfect. And that brings us to another key idea. Perception is reality, distinguishable versus definable. Just because a color can be defined in software with RGB and CMYK values doesn't mean your eye can see the difference once it's printed. As we showed earlier, two colors can be mathematically different, but if you can't tell them apart on fabric, then guess what? They are the same. It looks like a match to you, it looks perfect to your client, and it ultimately looks great in your bank account. Interestingly, there's science behind the forgiveness. There's actually a scientific term called delta E. It's a unit that measures how different two colors appear to the human eye. In plain terms, it measures how noticeable a color difference feels to a person. But let's talk about delta E in practical terms. A delta E of under 3 is generally considered indistinguishable, even for brand work, meaning under ideal lighting conditions, the human eye cannot tell the difference between, say, like one red and the other red. A delta E of 4 or more starts to become noticeable to most people. And a delta E of 8 to 10 plus, the difference is obvious, even in bad lighting conditions. So while the color math might show a massive loss going from screen to print, your eye likely sees a match, and so does your client. So let's recap again. RGB, 1 to 5 million distinguishable colors. CMYK, 100,000 plus for a good DTF system. But in the real world, your eye smooths most of it out. And that's the difference between theory and reality. Now, what should you actually do with this knowledge? Here's a cheat sheet. Start by listening to what your customer wants. Their expectations should shape your workflow. So for example, let's look at two separate scenarios. Scenario 1, the customer wants bright, bold color, and that's it. They're not worried about exact matches. They just want it to look vibrant and feel good on a shirt. Great, you've got flexibility here. Design in any tool you want. Canva, Photoshop, Illustrator, whatever. Accept client supplied files, doesn't matter. Just check for resolution and transparency. Trust your printer and RIP software to do the rest. At Demand Prints, our expanded Gamut and professional RIP software does a great job translating the colors to produce vivid, high-impact color results. In most cases, you don't need to overthink it. Here's scenario 2. the customer needs exact brand color matches. This is a completely different game. These clients, usually brands, sports teams, corporate accounts, they care deeply about color consistency. For them, you really should use professional design tools like Illustrator or Photoshop. Design in CMYK mode, use spot colors or Pantone libraries if you can, and communicate with your print provider using proper terms. Be prepared to run test prints or color variations for final approval. We'll break down this workflow, including how to build and use spot colors, in a dedicated video later in the series. But for now, just know this kind of precision is absolutely doable. It just requires a more intentional setup and workflow. In the next videos, we'll go deeper into spot colors, Pantone matching, file types, file prep, and more. And all of that will make a lot more sense now that you've got this core knowledge in place. I'm Paul from Demand Prints. We hope this was helpful. Thanks for watching, and we'll see you in the next one.